Hi guys, so today we're going to be discussing one of the solutions to first order differential equations, and that would be the separable equations, or otherwise known as the variable separable. Before we solve some problems regarding separable equations, let's talk about the form of the separable differential equation, or separable d. So the form here is dy over dx equals m of x over n of y, wherein m of x here is a function in terms of x, and n of y is a function in terms of y. So to solve for its solution, what we would do here is we will just have to rearrange the equation so that n of y is on one side of the equation and it is multiplied with the differential dy, while m of x is on the other side of the equation and it is multiplied to the differential dx. Once we've separated n of y and m of x, the next thing to do is to integrate both sides. So that will get us the general solution of our separable dE. And once we've solved for its general solution, I always simplify them into this following form. So the first form here is the explicit form, wherein y is separated from the terms containing x, or it could be in this implicit form wherein I have here f of xy on the left side of the equation, and on the right side we have here the arbitrary constant c. Let's now try to solve problem number 1 using separable equation. So we have here the dE y squared dx equals 1 minus x dy. So what we would do here is we would have to cross multiply so that I would have dy over y squared on the left side of the equation, and on the right side I would have dx over 1 minus x. Since the variables here are already separated, the next step here is to integrate both sides. Now, to easily integrate the left side of the equation, I can bring my y squared up to the numerator so that I would have y raised to negative 2 dy. Then I would just copy the right side of the equation. So I would have dx over 1 minus x. Now, to get the integral of the left side of the equation, I will use here the reverse power formula. And it states that if I have here the integral of u raised to n, so that would be equal to u raised to n plus 1 over n plus 1. So using this reverse power formula, the integral of y raised to negative 2 dy would be negative, or I mean, y raised to negative 1 over negative 1, or simply negative y raised to negative 1. Now, on the right side of the equation, so to integrate this one, I will use a u substitution. So I will let here u be equal to the denominator 1 minus x. I would need to get the derivative of u with respect to x. That would be negative 1. Then since I'm using u sub, I would need to have an equation for my dx. So I will rearrange this equation here so that dx would be equal to negative du. So I can now replace these terms here on the right side of the equation so that I would have here negative integral of du over our denominator is u. So the integral here of du over u is just ln, or natural logarithm of the absolute value of u. Then don't forget the arbitrary constant c. So I would just copy here the left side of the equation, negative y raised to negative 1. Next step, so I can now replace u with 1 minus x since I've already solved for its integral. So I would have here on the right side negative natural logarithm of the absolute value of 1 minus x plus c. As for the left side of the equation, so I can make this exponent positive by bringing this down to the denominator. So I would have here negative 1 over y. Then the next step, I can multiply both sides by negative 1 so that I can remove the negative sign from the left side of the equation. So I would have here 1 over y equals, this term here would be positive. So I would have here ln of the absolute value of 1 minus x, plus we have here negative 1 times the arbitrary constant. So that would still be an arbitrary constant. Okay? So the final step here is by looking at this general solution, I can transform this one into its explicit form. So the final answer here would be y equals 1 over the natural logarithm of the absolute value of 1 minus x plus c. So I've just performed cross multiplication so that I can isolate variable y. Let's now solve problem number 2. I have here the equation cosine x cosine y dy plus sine x sine y dx equals 0. Let's transpose this term here on the right side of the equation so that I would have cosine x cosine y dy equals negative sine x sine y dx. Next, to separate the variables, let's cross multiply cosine y and sine y so that I would have cosine y over sine y dy on the left side. Then on the right side, I would have negative sine x over cosine x dx. Next step, perform integration. To integrate the left and the right side of the equation, we will use substitution. So I will start here on the left side of the equation. I will let u be equal to the denominator sine y. Next, I would need to get the derivative of u with respect to y. That would be positive cosine y. Then, solving for du, my du here would be equal to cosine y dy. So, I can replace here the left side of the equation with the integral of du over u. And that would be equal to the natural logarithm of the absolute value of u. So, plugging in my u, the integral here would be equal to the natural logarithm of the absolute value of sine y. As for the right side of the equation, I will also perform again u substitution. So I will let u this time equal to cosine x, and my du would be negative sine x. So solving for du, my du here would be negative sine x dx. So I can rewrite the right side of the equation in the form du over u. So it would be the same as on the left side. So its integral would be natural logarithm of the absolute value of u. So if I plug in u here on the right side of the equation, I would have here the natural logarithm of the absolute value of cosine x. So if I combine these two integrals, I would have the natural logarithm of the absolute value of sine y on the left side, and on the right side, I would have here the natural logarithm of the absolute value of cosine x. Then don't forget to place an arbitrary constant c. The final steps here is let's convert this general solution into its trigonometric form by applying exponential on both sides. So I would have here e raised to the natural logarithm of the absolute value of sine y equals e raised to the natural logarithm of the absolute value of cosine x plus c. So the exponential function and the logarithmic cancels out here. So I would have here sine y on the left side. Then on the right side, I can rewrite this as e raised to the natural logarithm of the absolute value of cosine x multiplied by e raised to the constant. So we've used here the laws of exponent. So e raised to the arbitrary constant here is still a constant. So I can rewrite that one as c. Then as for e raised to ln of the absolute value of cosine x, that would just simply be cosine x. So I would write here sine y on the left side of the equation. So the final answer here would be, if I express this one in this form, that would be sine y over cosine x equals c. Let's now proceed to the third problem. We have here the dE xy dx minus x plus 2 dy equals 0. So the first step here is I would need to transpose this one so that I would have here a positive term. I would have x plus 2 dy equals, on the right side, I would have here xy dx. Next step, I would need to cross multiply so that I would have here dy over y on the left side of the equation. Then on the right side, I would have x over x plus 2 dx. Since the variables here are already separated, we can now perform integration. So on the left side of the equation, that would just be the natural logarithm of the absolute value of y. As for the right side, I would need to perform here u substitution. So I will let u be equal to x plus 2. Let's get its derivative. So with respect to x, so that would just be 1. Solving for du, that would just be equal to dx. Then aside from these two equations, I would need to have an equation for x. So I will use here this equation. So if I isolate x here in this equation, I would have x equals u minus 2. So I can now substitute these three equations on the right side of the equation. So I would have here u equal to u minus 2, dx equal to du, then x plus 2 equal to u. So simplifying the right side, I would have here integral of, I can distribute my denominator. So u over u is 1 minus 2 over u multiplied by the differential du. So I can now integrate them. So the integral of du would just be equal to u, while the integral of 2 du over u would be, I will have here minus 2 times the natural logarithm of the absolute value of u. And since we've finished integrating, I would need to add an arbitrary constant. As for the left side, I would just copy this one. I would have here the natural logarithm of the absolute value of y. Next step, let's now replace u with x plus 2. So I would have here x plus 2 minus 2, the natural logarithm of the absolute value of x plus 2 plus the arbitrary constant c. So by looking at this general solution, so I can express this one into its explicit form by applying exponential on both sides or the antilogarithm on both sides. But before we do that, we can actually combine these two here with the arbitrary constant. So any value added to the arbitrary constant is still a arbitrary constant. So I can rewrite this as the natural logarithm of the absolute value of y equals x minus 2 natural logarithm of the absolute value of x plus 2 plus the arbitrary constant. So I can now perform exponential on both sides. So I would have e raised to the natural logarithm of the absolute value of y equals e raised to x minus 2 natural logarithm of the absolute value of x plus 2 plus c. On the left side of the equation, this would just be simply y. And as for the right side, by loss of exponents, I can rewrite the right side of the equation as e raised to x multiplied by e raised to negative 2 natural logarithm of the absolute value of x plus 2 multiplied by e raised to the arbitrary constant. So simplifying further, I would have e raised to c is just the arbitrary constant. Then I would just copy e raised to x here. Then to simplify this expression, so there's a property in logarithms wherein this coefficient negative 2 can be an exponent of x plus 2. So I can rewrite this as e raised to the natural logarithm of the absolute value of x plus 2 raised to negative 2. So I can cancel out the exponential in the logarithmic function, so that will leave us to y equals c e raised to x multiplied by x plus 2 raised to negative 2. So the final answer here would be equal to y equals c e raised to x. Then as for this expression here, I would need to convert this negative exponent into a positive exponent. And to do that, I would just need to bring that one in the denominator. So I would have here over x plus 2 squared. So this is now the final answer.